5-1, rational exponents and properties of exponents. You guys will be able to use properties of exponents to generate equivalent expressions with rational exponents. So example 1, understanding rational exponents. An exponent is a power, so 1/2 is the exponent. Rational means that the number can be put into a fraction. So 3 to 1/2, what does that equal to? To turn rational exponent into a radical, 3 is your base, that's the number that goes inside the radical. Then it's your base to the power, which is your numerator. And then the number on the outside is your root. So 3 to the first power, and then my root of 2. 3 to the first power is just known as 3, and any radical that's by itself, it's always known as a square root, so there is no need to write the 2 whenever it's a square root. And then here you have the power of a power property that states a to the m power, then to a n power equals amn. A power to a power, you multiply. Also, anything to the 1/2 power would be considered a square root. So 1/3, this would be a cube root. So 2 would go on the inside. It has a power of 1, so 2 to the first power would just be a 2. And then cube root, because it is a cube root, you do need to put the 3 on the outside. So this is a rational exponent converted into a radical expression. Next, we have 4 different examples of properties of exponents. Here we have a negative exponent. This does not mean that your answer is going to be negative. Your answer cannot have a negative exponent, so your very first step would be to get rid of that negative by making 1/25 into the reciprocal. So the reciprocal of 1/125 would be 125/1, and then that makes it a positive 1/3. So I don't need to put the over 1 part, so that would just be 1/25 to the 1/3 power, which then if you want to simplify this, this would be 1/25 to the first power. Again, I don't need to write the 1, cube rooted. So on your calculator, if you have the Texas Instrument, the gray TI 30XA, on top of the 0, you do have a cube root button. You can press 125, second shift, press your 0, and your answer comes out to a 5. Or on your calculator, you have a y to the x button. So you can press on your calculator 125, press your y to the x button, press 1, then press your ABC button, press 3, and then equals. That should give you a 5 as an answer. So your scientific calculator will come in very handy during this lesson. Next, how to show that these two rational exponents are equivalent. So we have 8 to the 1/2 and 16 to the 3/8. First, we can start off by trying making the bases the same. 8 and 16 obviously are not the same base, but how can I rewrite them to be the same base? Well, they both can have a base of 2, because I can do 2 to the 3rd power. That would give me an 8. And then that number to the 1/2 power. Next, 16 can also be written with a base of 2, but that would be 2 to the 4th power, and then that to the 3/8 power. So power to a power multiply. So 3 times 1/2 would be 3/2. Power to a power here would be 12/8, and I can simplify 12/8 by 4. 4 goes into 12 3 times, 4 goes into 8 twice. So 2 to the 3 halves, 2 to the 3 halves. So these two would be equivalent expressions. Next, I have 9a squared b to the negative third c to the negative 2 divided by 12a b to the negative third c to the fourth, all to the negative second exponent. Again, answers can never have a negative exponent as your end result. So to get rid of that negative, I need to do the reciprocal of this entire fraction. So whatever's on the bottom is now going to be on the top. And that numerator now becomes your denominator. And now that becomes a positive 2. So I like to work on the inside first, and then I'll do everything to the second power. So as a fraction, 12 over 9 can both be reduced by 3. 3 goes into 12 4 times. 3 goes into 9 3 times. Then one of your properties is your quotient property, which states that when you are doing division and you have the same base, you subtract your exponents. Any variable that's always by itself has a little 1. So if I do same base, and then if I do 1 minus 2, I am left with a to the negative first power. But I cannot have negative exponents. So to make 1 positive, I do the reciprocal 1 over a, which means a goes now to the bottom. b negative 3, very simple, cancels each other out. Another way that you can tell it would cancel out, if I do negative 3 minus another negative 3, that's a double negative, which turns into a plus. Negative 3 plus 3 is 0. Anything, any number, any variable, ever to the 0 power will always equal a 1. So b disappears. And then I have c4 minus a negative 2, double negative. That becomes c to the 6th power. It's positive, so it goes to the top. And then all of that to the 2nd power. So now I have to simplify. 4 squared, 4 times 4, 16, power to a power, multiply c to the 12, 3 to the 2nd power, 9, that has a little invincible 1, power to a power, multiply a squared, and that would be a final answer. And next, using properties of exponents to generate an algebraic expression that it would be equivalent to negative 8 to the 3t plus 2 power. So what causes powers to be added together? When you are multiplying the same base. So a negative 8 to the 3t power times another negative 8 to the 2nd power. When you're multiplying the same base, the base stays the same and you add your powers. Since they are not like terms, they cannot be added together. Out of these two, the only one that I'm able to simplify is negative 8 squared. That becomes 64. Bring down my negative 8 to the 3t. Power of a power is multiplication, so I can separate 3t and put negative 8 to the 3rd power and t on the outside. That's how 3t comes around. 3 times t, 3t. Then I can do negative 8 cubed, which would be negative 512. And this would be a final answer. I would never be able to multiply these two numbers together because you cannot multiply without doing your exponent first, and I do not know what t equals to, so therefore I am done at this point. That would be my final and complete answer. So now we have a triad of all four of these type of problems. So letter A, use properties of exponents to generate an expression equivalent to each of the following expressions. So 9, I can rewrite 9 with a base of 3 to the second power, and that to the 3/4 power. Power of a power, multiplication, that would be 3, 6/4, which can be simplified to 2 goes into 6 3 times and into 4 twice. So 3 to the 3/2 powers would be my answer. Next, I can break down 49 and do 7 squared to the negative 3/2 powers. 2 times a negative 3/2 would make it 7 to the negative 3rd power. The 2's cancel out. And because it has a negative exponent, I need to do the reciprocal of 7, which would be 1/7 with a positive 3, and then 7 to the 3rd power would be 1/343 as my final answer. Letter C, I see this entire fraction to the negative 3 power. So first thing I'm going to do is do the entire reciprocal of that fraction. So 5g to the negative 3rd, h5, k to the negative 5/2 over 3g to the 7/3, h negative 3, k negative 5, and now I have a positive 3. So now working inside, once I'm done everything inside, then I can do the power of 3 to everything. So 5 and 3 cannot be simplified, so 5 stays on the top, 3 stays on the bottom. When you are dividing, we subtract the powers, so a negative 3 minus a 7/3. If you have a scientific calculators, you can just go ahead and subtract that. If you don't, make the negative 3 as a fraction, put it over 1, find a common denominator, which is 3. 1 goes into 3 times, so that turns into a negative 9. Minus 7 is a negative 16. Denominator stays that same. Since that's a negative, g now needs to go to the bottom to become a positive 16/3. Because remember, this would end up being 1/g to the 16/3, so that's why it goes to the bottom. Next, I have my h. 5 minus a negative 3, double negative, so that becomes h to the 8th. Positive goes to the top. Then I have k, negative 5/2 minus a negative 5. Make that as a fraction. Common denominator between 2 and 1 is 2. 1 goes into 2 times, so 5 times 2 would be 10. Negative 10, double negative. Negative 5 plus 10 is a positive 5/2. Positive goes to the top. All of this now to the 3rd power. So k, 5 to the 3rd power, 5 times 5 times 5, 125. Power to a power, multiply 8 to the 24, 5/2 to the 3rd power, k to the 15/2, over 3 to the 3rd power, 27. And then 16/3 to the 3rd power, the 3's cancel out, so 16g to the 16th power would be your final answer. And then letter D, simplify that. So again, what would cause adding exponents would be multiplying the same base. So 5 to the 2t power times 5 to the 3rd power. The only one I can simplify here is 5 to the 3rd power, which would be 125, times 5 to the 2t power. Then power to a power, you end up multiplying. So I can separate the 2 and the t. And then 5 squared would be 25. And the t stays there, and nothing else I would be able to do with this problem. Next, evaluate the product, which means I need a final answer. When you're multiplying and you have the same base, add your exponents. So 3 stays the same. I already have a common denominator, so 5 stays the same. 27 added to 18 would be 45. I can simplify that, make it 3 to the 9th. Again, use use this button on your scientific calculator. It's on top of the division if you have the gray calculator. And then 3 to the, press that button, press 9 equals, and your final answer would be 19,683. When you are dividing, you now subtract your powers. So 27 over 4 minus 11 over 2. We need a common denominator, which is a 4. 2 goes into 4 twice, so 11 times 2, 22. 27 minus 22 is 5 over 4. And it says to evaluate, so you do need an answer. So on your scientific calculators, 6, y to the x button, 5, ABC, 4 equals 2. And this gives you a decimal. More than likely, sometimes you'd have to round to the nearest hundred. So answer should be 9.39. If it tells you to evaluate, that means it needs what this could equal to. You can pause and try these on your own. So multiplication, same base, add your powers. 9 plus 6, 15. You already have a common denominator. 15 divided by 5 cubed. 2 cubed is 8. When you are dividing, you subtract your exponents. So 17 thirds minus 13 thirds, same denominator. And then 17 minus 13 is 4. Again, you can use your calculator. 125, y to the x button, 4, ABC, 3 equals, answer should be 625. Also, if you would write this as a radical, it would be 125 to the 4th power and then cube root it. If you don't have that y to the x button, you would do 125 times itself 4 times and then cube root that number. So these are your different properties. Power of a power, when you only have one base and you have a power and that to another power, your base stays the same, multiply your exponents. When you have a product inside parentheses to a power, everything inside that parentheses gets done to that power on the outside. Multiplication, keep your base, add your powers. Division, keep your base, subtract your powers. Here are just some more examples. Write each radical using rational exponents. So now we need to convert these into the base with the power over root. So any number that's by itself always has a power of 1. Any radical that's always by itself is always a square root. So that's 7 to the 1/2. That is 15. Power of 1 square rooted. So 15 to the 1/2 power. This would be 6, power of 4 with a root of 3. So 6 to the 4 thirds. And if you're ever able to simplify your fraction, simplify it. So 2, power of 3, cube rooted. 3 divided by 3 is 1. So this would just be a 2. Use properties of exponents to determine whether the expressions are equivalent. We can rewrite them using the same base. They both can be written by a base of 3. So 3 to the 4th power would give you 81, and that to the 1/3 power. Power to a power multiplied would be 3 to the 4 thirds. then 9 can be written as 3 squared to the 2/3 power. 2 times the 2/3 is 4/3. Power to a power multiply, so that would be a6, b8, and the only thing I would have to do here is multiply the b squared to the 4th power, and a6 stayed the same. Power to a power multiply. 12 through 15, use properties of exponents to generate an expression equivalent to each given expression. First, I see that this is a negative exponent. Do the reciprocal, and anything to the first power is basically itself. So n stays goes to the top, m squared to the bottom. 13, subtract. So I have 25, 11 over 4 minus 9 over 4, which makes it 11 minus 9, 2 over 4, gets reduced to 1/2. We should know anything to the 1/2 power is a square root. Square root of 25 is 5. Or if you type this on your calculator, it should still give you a 5. Power to a power multiply. 1/3 of 9 is a 3, and then 4 cubed is 64. Power to a power multiply, so that makes it p to the -3rd and q to the 6th. Since p has a negative exponent, final answers cannot have negative exponents, so to make that 3 a positive, it needs to go to the denominator and make it a positive p to the 3rd, and that is 5-1.